So let's now take a look at problem 2. So problem 2, we have to make this 6-membered ring with a methyl group sticking off it and a ketone up here. And we have our starting materials is just methylene chloride and ethyl acetate. So how are we going to do this? And I'm thinking this has 4 of these. That would be, there's 2 carbons each. But we have to end up having 7 carbons on here. So we have to think about it. We have to make a lot of carbon-carbon double bonds. Been given a little bit of a clue. We're going to use 4 of these molecules. That makes me think right away a couple of things. I'm probably going to want to do Claisen condensation of this reaction so that I can get to the acetoacetic ester synthesis. You'll remember that from class. So let's do a little bit of a retrosynthetic analysis here. Even though I didn't ask for it, I'm going to go ahead and do one. We need to make a cyclic molecule that has 7 carbons. Obviously, we'll need to make a lot of carbon-carbon bonds. We'll have to figure out how to make the cyclic system. So how are we going to do that? Let's do a retrosynthetic analysis. Whenever we see this alpha-beta unsaturated ring, we want to think about an intramolecular cyclization from a 1,5-diketone. So here we have a ketone and 1, 2, 3, 4, 5 on the 5 carbon relative to that. We have another ketone. So if we can make this nucleophilic and attach it to this carbon, we can go ahead and do our cyclization reaction, and that's easy enough. So how do we make this? Well, we're going to make this from a couple of molecules of acetone. Actually, we're not going to use acetone. We're going to use a synthetic equivalent of the enolate from acetone. So let's go ahead and do our synthesis. Okay. This is a synthetic equivalent for the enolate, as I mentioned. So let's go from the start. The first thing we're going to do is a Claisen condensation to make our ethyl acetoacetate. Here's the aceto group and here's the acetate. What's special about this? Well, we can easily pull off that carbon-carbon bond. Now, one of the things we want to see, we're showing the reaction from this, and we have to use at least 2 equivalents of ethoxide. But you know what? To make all this, we had to use ethoxide. We actually quenched it. We didn't have to do that quenching step. We could have gone ahead, given this enough time to undergo the reaction, and then added the the methylene chloride, and that methylene chloride is going to get displaced by this carbon because that's our nucleophilic carbon. Once we make that, all we have to do is hydrolyze the ester. Now, one of the reasons we use base is because it works very well, very rapid, and then we just have to protonate afterwards and then heat it up, and that will get rid of all of these, and we make our 1,5-diketone, and we then use acid or base conditions to do an intramolecular aldol condensation reaction. It's that simple.